Dad, can you teach me how to tie my shoes?
Jeez, Chris, this reminds me of that time I had to explain decomposition to fourth period chemistry. Decomposition is one of the 5 main class reaction types, and I, Peter Griffin, love this form of reaction and want to tell you about it. I found an excellent video explaining the ins and outs of decomposition reactions.
What happens during a decomposition reaction? During this reaction, a compound breaks down into 2 elements or compounds, and we use the formula AB yields A plus B to represent it. There are 6 types of decomposition reactions. Firstly, a binary compound decomposes into its elements. Heat and electric currents are often used to break down compounds. For example, sodium chloride breaks down into sodium plus chlorine. Secondly, decomposition of a metal carbonate. Metal carbonates decompose into carbon dioxide and a metal oxide. For example, barium carbonate breaks down into carbon dioxide and barium oxide. Thirdly, decomposition of a metal nitrate. Metal nitrates decompose into a metal nitrite and oxygen. For example, sodium nitrate breaks down into sodium nitrite and oxygen.
Fourthly, decomposition of a metal chlorate. Metal chlorates decompose into a metal chloride and oxygen. For example, magnesium chlorate breaks down into magnesium chloride and oxygen. Fifthly, decomposition of a metal hydroxide. Metal hydroxides decompose into metal oxides and water. For example, potassium hydroxide breaks down into potassium oxide and water. Sixthly, decomposition of a nonmetal oxyacid. Nonmetal oxyacids decompose into a nonmetal oxide and water. For example, nitric acid breaks down into dinitrogen pentoxide and water. And that's decomposition reactions explained quickly. Thank you for watching. Make sure to subscribe to our channel for more chemistry videos. Don't forget to press the notification bell. Comment down below any questions you'd like to see answered next.
So pretty much, decomposition reactions are all about breaking down a compound into simpler elements, or other compounds. We can represent this process with the formula A plus B yields A plus B. There are 6 main types of decomposition reactions to know. First up, as she says, we have binary compounds, which split into their individual elements. Heat or electric currents often help in this breakdown. For instance, sodium chloride can decompose into sodium and chlorine. Next, we look at metal carbonates. These compounds break down into carbon dioxide and a metal oxide. A good example is barium carbonate, which decomposes into carbon dioxide and barium oxide. Then we have metal nitrates. When these decompose, they turn into a metal nitrite and oxygen. Sodium nitrate is a classic example, breaking down into sodium nitrite and oxygen. Moving on, metal chlorates decompose into a metal chloride and oxygen. For example, magnesium chlorate breaks down into magnesium chloride and oxygen. Fifth, metal hydroxides decompose into metal oxides and water. Take potassium hydroxide, for instance. It breaks down into potassium oxide and water. Lastly, nonmetal oxyacids decompose into a nonmetal oxide and water. A prime example is nitric acid, which breaks down into dinitrogen pentoxide and water.
But how do you identify a decomposition reaction?
Well, I'm glad you asked. You see, a decomposition reaction is identified by having only one reactant that breaks down into 2 or more simpler products. Meaning on the left side of a chemical equation there will only be one compound, while on the right side there will be multiple products. Essentially, a single substance decomposes into multiple substances.
I see. Thanks, Peter. I'm ready to do decomposition experiments now.
Well, hold on now. You can't forget about the rules.
Rules? There's rules to chemistry.
Why, of course, Timmy. The rules of a deposition reaction are as follows. In a decomposition reaction, the rule for product formation is that a single reactant breaks down into 2 or more simpler products, meaning the products will always be the constituent elements or smaller compounds that make up the original reactant. Essentially, the compound decomposes into its parts when energy is added. Some examples of decomposition reactions would be 2HEH converting to 2GLO plus O2G, SaCO3ACO converting to COS plus CO2G, and 2 NaOOSs converting to not 2OS plus H2OG.
But this is all just silly chemistry that doesn't affect my life.
Ah, but you are sorely mistaken. It does occur every day. For example, fizzy drinks. When you open a soda, the carbonic acid inside decomposes into carbon dioxide gas and water, causing the fizz. Here's a video of it in action.
Did you ever think of taking a salt in your hand and burning it to produce two gases out of it? If you haven't, let's try that in this experiment. So before we begin, let us see what all we would require in order to carry out this experiment. So we would require a dry test tube mounted on a stand. The major ingredient of this experiment for us is the ammonium chloride salt. We are going to burn this salt and produce two gases out of it. So open this and take about 5 grams of ammonium chloride and put it in the test tube. Let's start doing that. I think this should be enough. Roughly about 5 grams of ammonium chloride taken, and let's put it back to place. Next, since we have to decompose this salt, we are going to heat it with a spirit lamp, a small one but powerful. Spirit lamp is now lighted. Let's start heating the salt with this. Let's increase the height of the salt by a little. As you can hear the sound, there are some fumes coming from the test tube. We need to increase the height a little bit more. Yeah, this should be fine. So as you can see, the fumes coming out of the test tube, let's see what all it consists of. Let's also wear some protective gear. And let's take a blue litmus paper and bring it, slightly moist it. And let's bring it close to this. Let's keep it on the mouth for some time. So as you can see, it has slightly started to change color. And it's becoming a little red. You can see it at the boundary. It has started to turn red at the boundaries. That means there is a presence of some acidic element in the end products, and the acidic element that's present in the end product is the HCl gas. As you can see, a lot of it has changed to red now. So presence of HCl using this is confirmed. Now it's time for us to check what else is present. So we will be taking what is known as Nessler's reagent, K2HgI4 being the chemical formula, and we will dip it on a filter paper. So it's a colorless reagent in the beginning. This much should be enough. Let's place it at the mouth of the test tube. As you can see, the filter paper has slightly got yellow color now. This is because Nessler's reagent has reacted with ammonia, which was coming out as the end product, and hence ammonia was detected. So what all did we detect as our end products? We saw HCl because of the color change in the litmus paper, and now we've also seen ammonia. So NH4Cl, which was your original solid salt, has now decomposed into HCl gas and ammonia gas. So this way, we were able to produce two gases out of a single solid salt. Thanks for watching.
Wow, that's awesome. I had no clue this reaction was this common in our daily lives.
I can do this all day, little man. There is reactions everywhere and happening all the time, just most of them aren't visible to us.
Wow, I had no clue.
Let's go over it one more time. All right, little Timmy.
Okay, I'm ready.
First up, we have binary compounds, which separate into their individual elements. Heat or electric currents often facilitate this breakdown. For example, sodium chloride can decompose into sodium and chlorine. Next, we consider metal carbonates. These compounds break down into carbon dioxide and a metal oxide. A good example is barium carbonate, which decomposes into carbon dioxide and barium oxide. Then we look at metal nitrates. When these decompose, they turn into metal nitrite and oxygen. Sodium nitrate is a classic example, breaking down into sodium nitrite and oxygen. Moving on, metal chlorates decompose into a metal chloride and oxygen. For instance, magnesium chlorate breaks down into magnesium chloride and oxygen. Fifth, metal hydroxides decompose into metal oxides and water. Take potassium hydroxide, for example. It breaks down into potassium oxide and water. Lastly, non-metal oxyacids decompose into a non-metal oxide and water. A prime example is nitric acid, which breaks down into dinitrogen pentoxide and water. Do you understand now, little Timmy?
Yes, this makes so much more sense after you said it again.
Thanks for watching.